Absolute value equations. If we have the equation, the absolute value of x equals 5, what that's asking us is what value can x take on that will give us a distance of 5? Well, if we look at the different values x can take on, that's one variable, so it looks like a number line. If we look at that number line, we can tell over here on this side we've gone 5. It's in the negative direction, but it's a distance of 5. So if x is equal to negative 5, we've gone a distance of 5, or the absolute value of negative 5 equals 5. Also is the same case in the positive direction. At positive 5, we've also gone a distance of 5. So the absolute value of positive 5 is also 5. So we have two different answers for this equation. We have x is equal to 5 and x is equal to negative 5. Now we can do the same thing without even having to graph it. If we want the absolute value of x is equal to 100, well, that means we want a distance of 100, and we can go two different directions. We can go the positive direction and get x is equal to 100, or we can go the negative direction. X is equal to negative 100, so x again takes on two values. If we have something that looks like this, the absolute value of x is equal to negative 3, there's no solution that's going to give us that distance of negative 3. Our distance is always positive, so anytime you have an absolute value set equal to a negative number, you will get no solution. You can also write it like this, a little zero with a line through it. Here is one that's a little bit tougher. We have the absolute value of x plus 3 is equal to 2. Now, what that's saying is you want the distance of x when you add 3 to equal 2. So this in here, this distance has to equal 2. Well, that means inside this absolute value sign, we can have this be a positive or a negative 2, and that distance will be 2. So we're going to have two different equations. One that's equal to 2 and one that's equal to negative 2. So if we write our two equations, we have x plus 3 is equal to 2 and x plus 3 is equal to negative 2, then we go ahead and solve for x. In this case, we're going to subtract a 3 from both sides, and we have x is equal to 2 minus 3, or 2 plus a negative 3, which is negative 1. If we do this equation, we're going to do the same thing. We're going to subtract the 3 from both sides, or add a negative 3, however you want to think of it. And we have x is equal to, this makes it 0, negative 2 plus a negative 3, which gives us x equals negative 5. Now we can check that out in our original equation to make sure it works. So we have x plus 3 is equal to 2. And instead of the x, we're going to substitute in our x equals negative 1. So we have the absolute value of negative 1 plus 3, and we say that's supposed to be equal to 2. Well, negative 1 plus 3 is 2, and that's still equal to 2. And the absolute value of positive 2 is 2. So that one checked out. Now let's try x is equal to negative 5. So instead of x, I put a negative 5. Negative 5 plus 3, that gives me a negative 2. The absolute value of negative 2 is equal to 2. And again, I've shown that my equation is true for both of these values. Let's look at what happens when we have something multiplied by our absolute value sign. So in this case, we have 3 times the absolute value of x plus 5 minus 4 is equal to 5. Now, what we're going to do is just treat this like a regular equation until we get down to the absolute value sign, when we can actually look at what that distance should be. So we're solving for the absolute value, and then we'll go on to solve for x. So the first thing we want to do is add a 4 to both sides. We're trying to isolate this. So add a 4 to both sides, and we have 3 times the absolute value of x plus 5 equals 9. Now we're going to divide both sides by 3. This 3 is not inside my absolute value sign there. Divide by 3, divide by 3. Now we have 3 over 3, which is just 1, times the absolute value of x plus 5, and that's equal to 9 divided by 3, which is 3. Now what this says is we want our distance inside here to be 3. So in here can be a 3 or a negative 3, because when we take that distance, we get 3. So we've got two equations. We have x plus 5 is equal to 3, and we have x plus 5 is equal to negative 3. And we can go ahead and solve those equations. Subtract a 5 from both sides, And we have x is equal to 3 plus a negative 5 is going to give me a negative 2. And then we can do the same thing over here. Subtract a 5 from both sides, and x is equal to negative 8. And I can go ahead and check these values, and I could go all the way up to this equation, but I don't need to do that. I just want to kind of check to make sure that my values came out right. If I were doing a test, I would definitely want to plug it back in here, but I'm just going to do a quick check, a quick visual check, and I'm going to plug in x equals negative 2. Instead of my x right here, I have a negative 2. So I have the absolute value of negative 2 plus 5 equals 3. Negative 2 plus 5 is 3. Absolute value of 3 is 3. And that checks out. Same thing with negative 8. Put in a negative 8 for x. And I'm going to add 5 to it. If I take the, do this calculation, I get a negative 3 and take the absolute value. The absolute value of negative 3 is positive 3. And that checks out as well. Let's look at our last example. 1/2 times the absolute value of x plus 5 plus 3 equals 10. We're going to do the same thing. We're going to isolate this absolute value. So the first thing we're going to do is subtract 3 from both sides, or add a negative 3. And we have 1/2 times x plus 5, and this gives us a 0 right here, and that's equal to 10 minus 3, which is 7. Now we're going to multiply both sides by 2 so we can undo that 1/2 here. We would like this to be a 1 times our absolute value sign. So in order to do that, we're going to multiply both sides by 2. Remember, we have to do it to both sides of the equation. And multiplying by 2, we have 2 times 1/2, which is just 2 over 2, or 1. And that's just x plus 5. 1 times x plus 5 is x plus 5. And that's equal to 7 times 2, which is 14. Now here we have two different values that can be inside that absolute value sign and make this equation true. We could have a positive 14 or negative 14. So now we have two different equations, and we have x plus 5 equals 14, x plus 5 equals negative 14. We're going to subtract a 5 from both sides, and we have x is equal to 9. Subtract a 5 from both sides, and we have negative 14 plus a negative 5, which is negative 19. And I'm just going to do a quick check, a quick eyeball check in here. If I put in a 9 there, I get a positive 14, and that's equal to 14. And if I put in a negative 19, I get a negative 14. The absolute value of negative 14 is 14. Now, if you ever have something that looks like this, don't be fooled. So right here, you cannot set x minus 7 equal to negative 2 over here. Because when you take the absolute value of something, you're talking about positive numbers. Our distance is greater than 0. Absolute value is always positive. So if you ever have an absolute value set to a negative number, you know that there's no solution.